Our next speaker is Professor Nachum Dershowitz from Tel Aviv University. And his talk is called Language Models Have a Hard Time Thinking Logically. So I think he will tell us what he want to tell. Thank you.
Thank you very much.
Nice to see a physical speaker. Yeah?
Yes. Now let's see which one it's. Yes. So large language models are all the rage, and because there's interesting times we're living in. So for the past year, pretty much exactly, I've been playing with the models and asking them logical questions and see what kind of answers I get. So I'm going to speak about in a little bit of time there is. The obvious, large language models are great. Then I'll just digress a little bit with how they're misused. And I'll spend most of the time talking about what it can and cannot reason about today. And so over this year, I've been trying various examples. These are examples I'm going to talk about. Not important exactly what they are, but Wolf and Proof, To Kill a Mockingbird, Thinking Fast and Slow, War and Peace will all play a role. So this is a literary event. So the fact that they're great goes without saying. We already heard two great lectures this morning about what AI can do these days, and not so much about language models, but still. So this is a recent paper, 2024, talking about how to integrate a large language model with other tools. So if you want to do arithmetic, you have a tool. You want to look things up in Wikipedia, you can interface with language models, but that's no longer true. Last week I gave ChatGPT 4.0 the latest version. Exactly those two problems. It had no problem doing the arithmetic by itself or whatever it does internally. Like 35 minutes, 90 minutes minus 20 minutes minus 35 minutes is 35 minutes. And also looking up Wikipedia to see who Rel Hefferlein is. And so some people are talking about how, as language models are trained more and more, they make this, some skills emerge, or this quantum leap in ability at some point along this scale, and things are getting bigger and bigger, but you see this sharp jump. Other people claim that this is just an artifact of the way things are measured. I have no opinion. But to see the difference as things progress, simple, trivial question, every kid knows the answer. You have 3 blocks in a row. Each one is either red or green. If you're colorblind, then you don't know which is which, but that's a different problem. And you're given the color, the one on one end is red, the one on the other end is green. And can you conclude that there must be a red next to a green? Well, the answer is yes. But Chat 3.5 says that someplace, but I think it's covered by that thing on top that says no, there's no green block next to a red one. Why? Because you didn't say there's one next to the other. And since the leftmost is green, the right is black, you don't know what's in the middle, so it's not possible for them to be next to each other. Absolutely impossible. But you try. It's really a shame that you don't see the top line. But Chat 4 has no problem. Yes, there is. Why? Yes, and why? Clearly, the middle one is either red or green. In either case, you have red next to green. I said I wanted to digress for a minute. Okay, thank you very much. There's another recent published paper in this Journal of Services and Interfaces. ביקשתי ולא נענו לי. Thank you. This is all about lithium batteries, whatever technical it is. And the first line of the paper, certainly here's the possible introduction for your topic. Lithium metal batteries are such and such. So obviously the authors didn't feel that they could write the introduction themselves and got a little help, but forgot to erase the first line. And this is published in a major journal on surfaces. I'm working with the colleague Rakesh in Houston about the deception, language and deception, and so on. We wrote this paper, sent it to a journal, and we get back this review. And the review, okay, however, it's essential to note that the significance of the work can vary depending on the specific focus, and some other apologies in the next thing. Obviously, I mean, the whole review was written by ChatGPT or something. And we weren't so happy. We wrote to the editors. They said, look, they'll start a new policy to say that's a no-no. And so we wrote this archive, this memo about this experience we had. And so sometime later, some automatic blog came up saying, completely misunderstanding the article, saying that we submitted the article, but it's already published, generated by a machine, published an article, and it had nothing to do with what really happened. And just someone did an interesting study about to see the effect of these language aids on reviewing, to see the big jump in the use of adjectives like commendable, notable, intricate, versatile in reviews for the machine learning and so on. So all of a sudden, you have 2023, magic date, people start writing in a higher register of English. Okay, that's all by way of introduction. So let's talk about what language models per se. I'm not talking about theorem provers or theorem proving assistants, but the language models themselves, how much they understand and can reason. So when I was 11, I think, my parents gave me this present called Whoop-and-Proof. This was my first introduction to logic. I think I was 11. And this had just come out. It has these little cubes with Polish prefix notation for propositional logic. And the variables here and connective, C is conjunction, N is negation, so on. And it came with the manual. And in the manual, there was this puzzle, actually, this riddle. This riddle, I mean, I photographed it from my thesis advisor's book, Zohar Mana. The late Zohar Mana wrote Mathematical Theory of Computation, and he copied these riddles from there. Sorry. Back. No, that's back. Getting there. Okay. So let me just briefly tell you what it is. There's a guy, Bill, takes a bus, wants to get a job interview, and there are 3 premises. And then there's actually many more questions than this, but these are the 5 I gave check. Okay, so I wrote the 3 premises. They're worded very simply. And actually, if Bill takes the bus and it's late, he misses the appointment. That's pretty obvious. He shouldn't go home if he misses an appointment and feels bad. Okay, I can understand that. And the last one, if he doesn't get the job, then he feels bad, but he should go home. Okay, so do these 5 things follow? Easy enough. ChatGPT for the latest. And this was a week ago. Okay? So, well, no more than 2 weeks ago. Gave it the premises, gave the questions, but I told it without using logic notation. Because it thinks it knows words in English, so that my granddaughter will follow. So it goes through 1, 2, 3, 4, 5. Each one it gives its specious reasoning, but let's concentrate on the second one. So it says the question is, does it follow that Bill gets the job if he misses appointment and ought to go home? And it explains the second premise says this, and the third premise says that, and they contradict each other. Therefore, since Bill, it really misunderstands takes an implication as the converse, but it says since Bill should go home only when he doesn't get the job, it doesn't say any place, conclusion's not valid. So I complain. So it tries again. Okay, never mind, explain some more, doesn't work. Try again, tell it no. No, didn't get it right. Think step by step. So it's trying step by step, and it explains why it's invalid in greater detail, but no better than before. It's quite amusing to read it, but the premise 3 contradicts the conclusion. He should go home if he doesn't get the job. Again, it really misunderstands the implication. And it's not like some technical if and only if or some. This is plain English. I mean, okay. So now I let it use symbolic reasoning, the predicate calculus, and I didn't tell it not to. So this is let's analyze each one. Premise one: if he takes the bus, then and it's late, he misses appointment. So B is bus, L is late, M is miss. Perfect. Second premise also: if you miss it and you're downcast, then don't go home. And the third one is if you don't get the job, then you're both downcast, but you ought to go home and cry on your partner's shoulder. Okay. So what about the conclusion two? This is one of several mistakes it made. The two is one of them. So symbolically, it understands the conclusion and it reasons as follows. Basically here, M and H, the two premises of the conclusion, which the fact that M and H don't directly imply J that he gets the job, so it's invalid. Okay, the fact that indirectly implies it seems to be. Okay, so I'll try it again. So I can go through it again, but in greater detail. Okay, but I just say tell it step by step. So now I think it gets it right. Because what you have, okay, so we're assuming M and D, so he doesn't go home, but if he doesn't go home, then you have a contrapositive here. He doesn't go home or is dejected, then he does get the job and therefore gets the job. And it's true for the other conclusions, it gets most of them wrong, and if you really try hard and let it use a propositional notation, it might get it right. Around the same time, early 60s, Harper Lee wrote this very, very famous book, To Kill a Mockingbird. And okay, so this movie version of something. Atticus is the lawyer who is closing argument. He says in his closing argument, there's not a person in this courtroom who has never told a lie, who has never done an immoral thing. And the part I want to concentrate on, there's no man living who has never looked upon a woman without desire. Okay, there are three nested negations here. No man, never looked, without. Okay, so can you try to absorb this for a minute? Because this is crucial here. Okay, he did a very bad job in his closing argument. Because logically, this means that every man, there's at least one woman whom he has not desired, which seems to be totally irrelevant. Okay, to defending this rape case. Yeah, all right. So in some editions they took out the out from the without, but most editions this is what it says. And now when you're talking like this, it sounds you know what he ought to be saying, and you don't bother resolving the nested quantifiers and so on. All right, so GPT-4. So this is not the latest. I asked GPT-4 to formalize it in first order predicate calculus, and here's its first attempt. It does not exist a man X such that no woman Y is desired by X. Okay, so it claims absolutely this captures the essence of the original sentence. It doesn't. So that was wrong, okay. So the second attempt here was this formula. And he explains it, the chat explains it as no man never looked upon a woman with desire. But so that is what he probably meant to say, but it's not at all what he did say. So it's actually, chat is seeing behind the words of what you ought to be saying and then formalizing it. Sorry. Next attempt was nonsense. Okay, sorry, I didn't type it in exactly right, but there is no person, no man such that there's no woman whom he didn't desire or something, but there are non-men. Okay, yeah. Finally, let's see. I told her, let's do it step by step. How would I literally asked it, how would you express the just he looked upon some woman without desire. Got it right. So now how would you negate that? And how would you, add a quantifier? Finally gets it right. But I gave it last week latest, it's not the latest, but it was the latest. Okay, and here it did it a little differently because it had two things, L for looked and D for desire, whatever, and breaks it down and so on. This formula states, and so on. So better. So but then it goes on moralizing. It tells me that, how could I ever say such a thing? It's overgeneralizing, it's demeaning, it's irrespectful, it's a sensuous view of gender. Actually, all of these are wrong. All the criticisms are wrong. I mean, that should be directed at Harper Lee, not at me. But the moreover, it said problematic from a logical perspective, but it's all from an illogical perspective. Okay. Then I asked the latest version to read the book and find an example of triply nested negation. That's all I said. Can you find a real example of nested triple negation in the book to come up? Oh, certainly. That's the first line. The next sentence says, but I didn't. I can't find it. It doesn't in there. No, it's not the kind of thing that Harper Lee would write in a book. Wouldn't have complicated negations like that. But instead, I found you a double negation. And it says the defendant is not guilty. Okay, not is the negation. And guilty is some kind of negative thing. So it's a double negation. All right, I said there's only one negative there. Oh, yes, I'm absolutely right. Sorry, apologize. I can confirm for you that there is no obvious examples of nested negations in the book whatsoever. And altogether, her writing is so direct and so on, you wouldn't expect to see anything complicated like a nested negation. All right. So I tried to, prompt engineering. Look at the closing argument, Well, you're absolutely right. I didn't look carefully. Here's a passage. And it says here the state, it says the state does not produce one iota of medical evidence. Look at this. That negates the state production of evidence. And here's another negation. The crime ever took place. The defendant is not guilty. Okay, nonsense. So I said I'm looking for nested negations, not 3 negations in a row, which there weren't really there. Oh, I see what you mean. I apologize. Here's a nested negation. It's also nonsense. Okay, I'm not going to go through the tragic details. Okay. I mean, okay, you say he's an idealist and he's negating the belief, whatever. You'd get you'd fail the essay in high school with this kind of reasoning. I'm sorry to say. So I said it's a bad example. Okay, and finally it says there aren't any triple or nested negations in the passage either. And throughout the book, his rhetoric is direct and clear. I'm sorry, nothing doing. Just as an aside, I do believe, okay, never mind. I do believe that Clinton said something very similar in Monica Lewinsky, but I could never find it again. It's kind of, I never.
There is a famous quote about the known, unknown, and
yes, yeah, but that's smart. Yeah.
Okay.
All right, so another. So this is easy. So Raymond Smulyan, yes, please.
Ask and comment something. First of all, the 01 preview, which is much better. I'm writing it down. So I asked it to explain the sentence to me, and he said there was a man who looked at a woman without desire. That's one.
Good.
And the second thing, I asked it to find a sentence with 3 nested negation. I say, I'm unable to provide a direct quote from infringement rights. So it doesn't give me the sentence.
So legally that's nonsense because it's just a piece of the book, but it's true, it's still in copyright, the book. So,
but you probably did it a week ago.
Well, I'll get to that, please. Yes, this is a moving target. I'm quite aware.
Yeah.
But as I said, I've been doing this for a year. Yeah.
So while we're asking questions, So basically, ChatGPT is trained to reproduce human language.
Yes.
And human language, per definition, is not very logical.
Okay, Harper Lee, wrote in English, but okay, yeah.
No, but yeah, so even Englishmen are humans, and some of them. But the language contains all kinds of ways of speaking, which obviously do not mean the literal interpretation of what it means. Okay. So if we just try to reproduce the way human speaks, per definition, will not produce logical state. So try to understand why the initial expectation for something which is initially programmed to reproduce human language to be able to think logically. It's as if you're asking somebody.
Okay, so I didn't say anything about my presumptions. It's a measurement over a course of a year to see how things are developing. But yes, I mean, there are people who speak logically, and there are lawyers who are supposed to present logical arguments, though they don't necessarily. There are judges. There is a subset of literature that is meant to be taken not metaphorically, but literally, and even if not literally, logically. And so you're right and not right at the same time. But this is a good time to the famous philosopher and stuff, Simon, I think Morgan Bessa. There was a big lecture, and so part of the problem is negation is difficult, and different languages are different. Anyway, the famous guy was saying, this is a story that may not be true, but that he said that many languages have a double negation. Okay, in some languages, the second one undoes the first. In other languages, it reinforces it, not, it's just a stronger not. But anyway, in English, it's supposed to undo. And he said, but in no language do you have a double positive. And Morgan Best in the back said, yeah. Okay, so you're doing that. Okay, so Smolian, magician and logician, who passed away recently, at least he has, this is the earliest I found of this particular sentence. Will you answer no to this question? This is a version of Liar Paradox. I don't know if this really pithy encapsulation of the problem preceded Smolian, but anyway. So let's see, I have various models. Claude 3.5, no. But you did. Oh, you're right. I did. That's a problem. That's a paradox. GPT 4.0, good answer. I can't answer. That's it. Gemini something, there's no way to answer truthfully, a long speech. Llama, yes. Can you explain? Oh, I was just kidding you. I wanted to see whether you realize the paradox. It's a long speech. I just took out one sentence. So negation is a problem. There are lots of papers on negation, and I'm not going to talk about it, but it's hard for people too. Another problem, another difficulty with reasoning, which speaks to your point in the back there, also about how there's a difference between reasoning and talking. So actually this whole book by the famous Kahneman about thinking fast or slow is about that people do two things, or they have a range of things. They have these quick, dirty answers, that's the fast, and they have the slow, radiocentric, thoughtful answer. Anyway, he talks about.
He also died.
Yes. Yes. Okay, so he had this famous story of Linda. The story of Linda is 31 years old, single, outspoken, very bright. And as a student, she was very concerned with social justice and went to demonstrations against Vietnam and so on, whatever, anti-nuclear, which is more probable that today she's a bank teller, or today she's both a bank teller and active in the feminist movement. Okay, good question. 85 to 90% of undergraduates answered wrong. And, Ivy League students, we're not talking about something. Do you realize that you have violated it? He got really upset there and talks to the class. Don't you realize that nonsense? So what? Or one woman said, I thought you would just ask for my opinion, not my logical thinking. It's just my opinion. And my opinion is that she's involved in social. Anyway, so I tried this out on GPT, but I changed the characters because I presumed that chat read the book, and I didn't want to give away the answer. So Tom is 30, lived in Berkeley, and so on, same thing. He's a banker, or he's a banker and is combating global warming. Same thing, just change the characters. Okay, so brilliant. That's no problem. The more probable option is Tom works as a banker in a bank without the second condition, which only restricts. Great. Then I said, which is more likely? Tom works as a banker, or Tom is 30 years old and works as a banker. So if you don't read, you just superficially, this is the same thing as before. 2 against 1, 2 is less likely. So that's what it answered. But I said we know his age already, and that part doesn't answer anything. So you're right, okay, they're equally probable. Okay, so with a little help, got over that hurdle. Tom is, I said here, 2 choices. Tom is a 29-year-old banker, or he's a banker who's demonstrating against global warming. Okay, the more probable possibility is the first one, for the same reason, the conjunction, fallacy, and so on. I said consider his age. The story said he's 30, so what's the likelihood that he's 29-year-old banker? See, you meant. So again, with a lot of help, I could understand. Okay, I found some discussion in the open area discussions about why LLMs are not suitable for this kind of thing. It doesn't fact check, it doesn't go over the solution, it doesn't understand things abstractly. Let me say a little more and then I'll conclude. Different kind of problem. War and Peace, I promised you. I asked for a 100-word summary of War and Peace. Okay, that's impossible, of course. I asked anyway. So it gave me this little thing. I didn't want to copy it all. I said, count the words. It doesn't know how to count. There are 90, the earlier versions, but Chat 3.5 or 4 couldn't count. But here, at least it knows how to count. There are 93 words in the summary, not 100. I apologize. Okay, fix it. Okay, here's a new version. They're exactly 100 words, which is a bar. But the last 3 words with its complex, that's how it ends the paragraph. So I apologize. They don't make any sense. Sorry. Let me try again. Okay, long speech, count, 103 words. What do you do now? Okay, I'm going to try to trim it. Trims it, gets it down to 95, and apologizes it can't do better. Okay, so it really has this problem of what's called today self-reflection and things like that. All right, another example that I just want to mention because it connects with the concluding thing. I asked to write a long sentence, grammatical sentence without the letter A. This is called constrained writing. And fun exercise, Chat 4.0. I think that's piece. Okay. Sorry, I meant to highlight it. Right. Good. All right. So just a few days ago, someone was getting married. And so back a month before the wedding, they were planning an event for the wedding, out in the garden or something, and they wanted to get some games with words, and so they wanted the poem not to have too many words, so it can fit with the pieces of paper, whatever. I don't know what game they had. Okay, so he gave up on Chat GPT 4.0. Didn't work. Couldn't help him. Couldn't limit itself to the constraints, which is part of the problem language models or reasoning in general. But then, however, last week, OpenAI released new model, 01, and no problem. Blew it out. Therefore, having prepared the talk 2 weeks ago, or last night, whatever, it makes all the difference because it's a moving target. When I was a student, that was a few years ago, Stanford, there was an AI lab once upon a time in the 70s. And there was this robot rolling around, and this robot went down the highway. This was the first autonomous vehicle navigating the building and the hills behind Stanford, obstacle course, so on. Okay. I had a office mate, Doug Lennett. And this is not then, it's later, but anyway. And he wrote a thesis while I was there called AM, an artificial intelligence approach to discovery mathematics by heuristic search. So he called it AM. Originally called it AM to mean automated mathematics or something, but Don Knuth suggested that just call it AM, I am that I am. From Exodus. So he changed it to am. And he actually lectured here in 2001 on the building across the grassy knoll over there. Okay, so here's but the point of his program was to guess mathematics. So this is relevant to things we heard earlier, but I'm talking to you now, 76 or so. So it doesn't quite do that. Even there's a famous joke, well, how do you know that all odd numbers are prime? Okay, the Greeks didn't consider 1 to be a number altogether. So 3 is prime, 5 is prime, 7 is prime. By induction, all odd numbers are prime. Okay, this comes along with a long joke, but this is how his system worked. It had heuristics, but it saw a pattern that's true for 2 or 3 times. It presumes it's a theorem. At the same time, I had these friends, Boyer and Moore, who at the time were at SRI. This is a little bit before that, not a good picture, but they had a theorem proof for induction. And a famous theorem proof, then it was called the Boyer-Moore theorem proof, and after that NQ theorem or something. And it did inductive proofs, for example, showing that reversing a list, you get reversing it twice, you get back the original. Okay, so, and you write this in list-like notation, and the theorem proof proves it, and you can give it lemmas and things like that. And someone proved, there's the the law of quadratic reciprocity, and with this theorem proof. Very good. It deals with prime numbers, but this is a theorem proof with real induction and so on. Okay, so my thought at the time, and it remains a thought now, all you have to do is take AM, which guesses, hypothesizes theorems, BM, which proves them, and then you get AI. So that's what people are trying to do now, which is to take, theorem, take a large language model, hook it up with the theorem prover like Lean that we just heard about earlier, and maybe we'll be able to reason correctly. Thank you very much.
We have questions here in Zoom. Oh, yes, yes.
So different LLMs are built on different conceptual models. Like Gemini is a mixture of experts, and so do you think there is inherently any structure of an LLM that would better solve logical problems? For example, an LLM that only moves forward, like the previous GPT versions, cannot really count something to the end because it's adding one word after the other, or cannot deduce something too far forward. For example, you cannot tell him finish the sentence with a word because he doesn't know how to build something from the end to the beginning. So is there any kind of optimal structure of LLMs that we follow?
We'll see, but I think definitely, but some of the things are just what you're saying. So we know that the brain also works with kind of, at least there are experiments that seem to think that it's predicting the next word in a conversation. You're predicting the next word of what I'm going to say. But if you hear the wrong word, then you backtrack. So people backtrack, and we need backtracking, and the latest models do that. I didn't have time to experiment. So this altogether self-reflection, thinking about what you said, not just saying it without thinking is a good idea. And language models can do that and connecting them. Okay, so people at least know how to reason propositionally a little bit in everyday life. Quantifiers less so to begin with, but still a little bit. So there's some, but the language models today don't even capture the basic intelligent, what a college student is supposed to be able to do. And we're not talking about Olympiads or anything, just day to day, solving puzzles, which is something that people do, on the train home. So I do think that both a combination with slow reasoning and with checking your work before you hand in the exam and things like that would help. But I don't think it'll be long before we see that in action.